just still setting up a few things. Okay, cool. Sorry for the delay. We can get started. So, last time we dug into if, elif, and else. And let's just have a little bit of review on that, and we'll get into comparison operators. You know what? Actually, this is kind of part of it. So let's go through this first, and we'll kind of bring it all back together at the end. So just a quick refresher. We went over the 3 conditional keywords: if, oh, oh, elif, and else. These are the 3 keywords for writing conditions in Python. And what they allow us to do, specifically when some condition is checked and evaluated as true or false. So, excuse me. My voice is a little hoarse. It's a bit smoky here, so. Okay. So that's what we covered last time, and let's get into some of the comparison operators. And these are going to be largely what we use, not the only things that we use in the condition of our control flow statements. These are not going to be the only things. They're going to be maybe a majority of the time you're writing a condition, you're going to be using these. I mean, certainly you'll be using them a lot to write conditions. So, cool. So let's look at these. So this lesson, at the end of this, we want to be able to use and describe the common comparison operators. So let's look at the common comparison operators. So we have the equality operator. It checks if the operands on the left and right hand side are equal, and if they're equal, the expression will evaluate to true. If they're not equal, then it will evaluate to false. So the comparison operators, all of these are going to help us construct a statement that is evaluated as either being as either expressing a true or false value. So they're going to express a Boolean values. So here's an example: 5 equals 5. 5 double equals 5 gives us true. So this expression gives us true. And true if the two things being compared, that's true. If we had 5 equal to 5, 5 not equal to 5, that would be false, because 5 is equal to 5, obviously. Less than, greater than, less than or equal to, greater than or equal to. I'm going to say that these are fairly self-explanatory, and we've gone over these before, but it's good to get some refresher because these are important. Less than, greater than, less than or equal, greater than or equal. Okay. I think it's safe to say it can apply to any data type, right? I could see if the string hello is equal to some other string hi, right? Obviously these are analogous or even equal in meaning, this statement will be hello equals hello, and that's obviously that's going to be true. So with the equality operator, we can compare numbers as well as, and the same is true for not equals. It's a little different with less than and greater than, and less than equals and greater than equals. Less than 3, and it's not. We know it's not. It's equal to 4. So, and you can do this, but it's less obvious when we have. And by less obvious, I mean like Python won't do this. This will be hello. At this, but the reason I want to bring the features of Python, the language might do, and sometimes those assumptions might be right, and sometimes they might be wrong. Sometimes they might, the language might do something different than your assumption or whatever. But when the flip side of that is, as we're learning a language, we kind of have assumptions about what it might do under certain circumstances, or what it could do. And when you're designing a language, you kind of also have to make assumptions, right? And you kind of have to know, from a language design standpoint, you have to know what assumptions are safe to make and what assumptions may. So in this case, like, play this little experiment. Like, you could say, well, the string hello has less characters in it than the string hello there, right? So there is a lessness about this, right? But it becomes less obvious. Let's say we had a couple of lists, and let's say we had was less than right. So right, which one of these would you make less, right? And on the left is, but the sum of these elements is certainly greater than the sum of the elements in the other list, right? So maybe should back to the string example, if strings could be less than, right? Like, do we do something like this and then like sum the lengths of the, see, like, so we're kind of chasing this long, difficult chain of assumptions, right? So hopefully you can see like the level of complexity that you would have to start thinking about in order to reason about code where collections or sequences such as strings or lists or tuples could be thought of as less than or greater than each other. That kind of reasoning gets complicated really quick. And that's what's important to know here. It's kind of just more trouble than it's worth. So we can use integers or floats or whatever. Oftentimes, you do want to compare the lengths of things. Was what you were than another, you could do that, You just use the len function, and len takes in any sequence, anything that you could string, a tuple, I believe a set also has a length, and a dictionary, if you do like dictionary.items or .values or .keys, then you can get a length from those things. Range would also have a length. So you can reason about these things in terms of their length, but you have to be explicit. And the same is true if we wanted to do the sum, right? We could do numbers greater than the sum of this long list with small numbers. The thing about not making that assumption is it just asks you to write explicit code, right? So from a language design standpoint, and from a development standpoint, you don't have to learn like with sequences. So the only reason, this might be obvious, this is probably pretty obvious This may be pretty obvious to some folks, but I do just want to. I'm just mentioning this and giving this some special attention because I have had a number of people kind of ask about this. And I've just, like I watch people code for a living basically. So I see this kind of mistake or this kind of assumption being made. I don't even want to call it a mistake because it's a totally reasonable thing to say, well, if I have hi should be less than hello, right? That's a reasonable thing. But just remember when you're doing that, you want to do len of both of these. Something like that. So two are sort of universally applicable, and you less than or greater than, they're all worth, you have to know them all, but yeah. Okay. Cool. So back to the role that these operators play. So these, remember, these all of these expressions, and some of these aren't valid. I could do let me just make these valid really quick, just so we're clear about this. I don't know, we'll just do that. So these are all valid expressions now, right? And the reason I keep calling them expressions, you'll hear the word expression and the word statement. An expression is a line of code that expresses a value. And the kind of value that it expresses will take the form of one of the data types that we've talked about. And there's some of the data types that we haven't talked about yet. But for example, a line of code that that gives back an integer, you could think about that as expressing that integer, right? All of these lines of code express a Boolean, right? And in fact, we have multiple expressions in some of these lines of code, right? So, hi, this is I know if something is an expression. You can print it off, and if you don't get an error, then and if you see the output, then it's an expression, right? So it's expressing that value, and the print is showing you the value it expresses. So the len of the string hi, the length of the string hi, it can't take the length of, like an integer or a float, which in Python isn't thought of as having a length. So so this expresses an integer. This expresses an integer. These are compared with this comparison operator, this Boolean operator, and compares them, and then that whole line of code expresses a Boolean. So I know I'm throwing around that word expression a lot, and I just want to be clear about what that means. So all of these express a true or false value. That's an important thing to note here because we're talking about conditions. And a condition is any line of code that expresses a Boolean value in the context of using it in conditional control flow. So let me get back. The conditions you use must always resolve to a Boolean value that's true or false. One common way of constructing an expression that resolves to a Boolean value is to compare two objects using see above. That's what we've just been talking about. Okay. Yeah, okay. I think that's basically good. All right. So let's move on to the challenges. So fill in the contents of the is old enough to drink function. This function takes in a number called age and returns whether a person of this age is old enough to legally drink in the United States. If the person is so note the legal drinking age in the United States is 21. So if we put in any number that is 21 or higher, then this function should return true. We'll get to that in a second. So we could say if we're equal to 21, right? So again, right, the greater than or equal to operator is going to compare the number called age with the number 21, and it's going to see if age is greater than or equal to 21, right? And if age is like 29, for example, then this expression will be true, and then this if will see a Boolean value of true right here, and it'll say, okay, so I'll execute the body of code. And in this case, if age is greater than or equal to 21, we'll return true. Otherwise, we'll return false. That expression from the if was false, we're going to do this instead, right? And remember, an else terminates a conditional chain. The chain can be terminated after an if or an elif, but it can't be continued after an else, right? Like when you have an else, that's just the explicit end of that chain of conditions. As an if is the explicit beginning of a new chain of conditions. Cool. So we just have a chain with two links in it, and if age is not greater than or equal to 21, then we're going to return false. Cool. So this is one way to do this. Another way, we could use an elif here, although I think this would not be preferable, but it would be valid. So if you think about this problem as using an elif, we could do this. Elif age is, and kind of here I could say, so if elif age is less than 21, and I actually have to, right, okay, so that would be the complement, right? Then we'll return false. That'd be another valid way of solving this problem. That would work. Wait, is this asking to return true or false? Aha, yes it is. Good. We could swap these conditions or something. We could also just do this. We're just kind of running the, list of kind of random solutions now. We could use two ifs like this. That would also work. But the trick, I was saying earlier, there's a little trick. If you're writing a function that returns a Boolean value, return the condition itself. Remember that condition, age return true. Well, the expression age greater than or equal to 21 literally evaluates to a value of true or false. Let's do that. So I want to these solutions, I'll say. I think this is, in terms of being like, I don't know, Pythonic. I mean, this is hardly even sure, why not? I want to dissuade you though, if you're looking at a problem like this and this is what occurs to you to write that's fine. Like when you're starting and you'll get there. These two are a little shaky, but this if and else, like, this is okay. It's okay to code like this. Even though it's okay. Common thing that I'm sure, like, what I have is like the prime and cool. And it looks like the example code to drive, presumably this is going to be, I mean, probably the same thing. Old enough to drive in the United States is going to be 16. So we can just return age greater than or equal to 16, right? So the expression age, which is a number, right? That's something that when we call this function, we pass in a number to be represented within the function as the identifier called age. Is greater than or equal to 16, then we know this person is old enough to drive. And again, this expression, because of the, and that's what we want to express right there. Oops. Oh no. Cool. Feel free to ask any questions that you might have. The material in a way that like isn't making sense. If I say something that just doesn't make sense to you for whatever reason, feel free to ask in Slack. I'm not checking the YouTube chat, but I am checking the Galvanize Slack, so feel free to jump in there. Okay, old enough to vote. So that's going to be 18. It's going to be kind of a piece with the last two. So that'll just be return age greater than equal to 18. Cool. Getting a lot of mileage out of this kind of question. Is old enough to drink and drive, it turns out. So we're going to return false. Nobody's ever old enough to drink and drive. Wait, let's see. Is that given an age old enough to legally drink and drive in the United States? The drinking age is 21. It's always illegal to drink and drive in the United States. Oh, okay. So I'm actually right. So if the person is older than 21, in this case 22, the output should be should be false. I was gonna do this as a joke, but I was actually right. Whoever wrote this, it's because there's only a few of us on the team. Cool. All right, logical operators. By the end of this lesson, you'll be able to use and describe the common logical operators. So these are 3 keywords that kind of have a role that's really similar to the kind of look. They take in their operands and express a 3 keywords are not and an or, take a left and a right hand operand. Not only takes a right hand operand. There are certain but we actually just think about it as taking a single right hand operand. So, and it just, if the Boolean value is true, well, not true is false. And if the Boolean value is false, then not false is these and the comparison operators in terms of their function. Obviously they look different because they're actual written words rather than sort of operators. But they are operators. You know, they just look different. Boolean value, the things that they compare, they can be a variety of things, right? They can be numbers, for equal to or not equal to. They can be anything. They could be Booleans. They could be a variety of types. The logical operators, things that these can, not hello. I mean, I guess that would be goodbye, but Python doesn't know that, right? Like, or not hello would be like, I'm already here, not saying either hello or goodbye, right? You know, again, an example. So yeah, this kind of statement doesn't really make sense. So the only thing that not can handle is some not 37, the square root of x, not y greater than, and you can ignore the variables here, but we can just look at this as like, making some comparison. Come on. Of course that's not going to run. I'm just being silly here. Evidently. Print. Whereas y is greater than 3 is going to be true, etc. Cool. Okay. And an OR. So we could do something like if 7 is greater than 5, which is true, and 6 is less than 12, which is also true. And is going to give us a true value back if both, the whole and will give us a, if with or banana, this is going to give us true because one of its operands was true, right? So the only time you're going to get a false out of an OR is if both of the conditions are false. This comes in handy. So there's some ways you can sort of use these to consolidate code, right? So let's say I have if 7 is greater than font, hello, right? And let's say I want to do the same thing, LF banana is equal to orange, right? And let's make this a little more. Stir1 equals banana. Stir2. And if stir2 is equal to stir1, we also want to print hello. So if you find yourself writing code where you check two conditions and in the body of those conditions you end up doing exactly the same thing, well, I mean, in this case it's just a print, hello or whatever, but if these are each, like, let's say 5 or 15 or even 2 or 3 lines of code, it's wise to try to consolidate that. There's a programming principle, DRY, dry, which is dry, don't repeat yourself. So in this case I have repeated code, so this will work just fine, but in the interest of adhering to the dry principle with not repeating my code, I can actually just delete this and just replace this with an OR, right? So since both of those conditions concluded with the same consequent, right, which is the body of code that we execute, the consequence of either of these being true, we can just combine them into one condition so we don't have to repeat that code inside. There are cases where you end up with a really long condition, like either side of the or maybe you have multiple ors and ands and stuff. If I start doing that, what I do, you can break things onto their own lines. If you want to just create an arbitrary line break, you can use a backslash, and that will just ignore the line break. And I just like to put the or the and right under the if, and then that way I have this, like, to me this reads like really nicely. So this is just a kind of a way of beautifying your code after you've consolidated it. It doesn't shorten it to the minimum number of lines, but it makes it, I think, more readable in certain cases. In this case, it's a pretty short line with two simple conditions. So this, if I start to get that like sort of eye strain feeling, like, okay, I really got to take this line in, then what I start doing is just breaking it up and kind of trying to separate things and space things out, and that makes it much easier to reason about later and come back and maintain. So, okay, cool. So that's the result in the same code. You can just use an or, and that'll help save you some space. If I have, right, you can see where I'm going with this already, probably. And then I have like if 7 is greater than 5, and if stir1 is equal to stir2, then I want to print nested. So what I want to do here, I can consolidate this by putting in an and, like this, right? Green sort of feeling. You can break out your code onto multiple lines and kind of beautify it a little bit. I kind of like to straighten everything out like that. Again, makes it more readable. So that's a good use case for an and. I will say there are times, like if you have any other code, code in that parent condition is another if that has a consequent, then this is logically identical to an and. If you have something like print something to stay the way it is, right? And that's something that an and can't accommodate. So if you're like, okay, so if this is true, I know I want to do this, but I'm not doing anything else but nesting. If the only thing in the body of the if is another if, then you can just shorten it with an and that just consolidates things, makes things a little better. So these are good use cases for and or, and they can help you write really easy to reason about code that is, and we could do are not, but actually I could also, and I forgot to mention this, when I'm using and operands in their own sets of parentheses, like this, and this, if you do this by habit, which obviously I forgot to do, it essentially just makes your code easier to read and reason about, and it can, since easier and prevent certain problems. So this is what I usually do. Bound conditions, where we condition with and. So regarding the order of evaluations, or the order of operations, as it's usually called, not is evaluated before and is evaluated before or, which is evaluated last. They also forgot to do here. That's interesting. All right. So yeah, I think this is probably pretty self-explanatory, but this is just another example we have. Whenever you see input in our code like this, you can just imagine it's, from some outside source, from somewhere, right? Somewhere from the outside world. Num mod 2 equals 0 and num mod 3 equals 0, then we know the number is divisible by both 2 and 3. We know it's even and a multiple of 3. So like 6 or I guess 12. I guess we know it's a multiple of 6. That's what we know. So we could have done if num mod 2 or num mod 6 equals 0, but you can do it this way too. Yeah, then it'll print that out, and then we can check if num mod 3 is equal to 0, print something else out. If it's even, print something else out, etc. So here we can take in a string, and then we can say if not, so this means that we're going to invert the value of whatever this gives us. So what I like to do when I see a not is just kind of ignore it for now and just set it aside. And I kind of come back to that, right? So we have a not to come back to. That means we're going to get the opposite of whatever the Boolean value that expresses in these parentheses gives us. We're going to get the opposite of it. So we'll come back to that. So if the length of some string is less than 3, or the length of some string is greater than 10. So if that's true, then this code will not execute because we have the not here. So this is going to execute the code when the length of some string is not 3 and 10 characters, then it's gonna do this. Otherwise, it'll do something else. Cool. Special OR. Okay. Special OR takes two Boolean expressions as parameters and returns true or false, corresponding to the OR operator. Right, so I think this just wants us to wrap, or we can just return expression 1 or expression 2. We can do that. Nope, I'm going to get it wrong. Okay. Let's see what my error is. It should not contain the word or anywhere in the function body. Okay. So I'm not allowed to actually use or. Okay, good. So it caught me. I was trying to do it the easy way. Okay, so let's see. So I can say if expression 1, and now we know it's an expression. It's specifically it's a Boolean expression. So if expression 1, this is a valid condition all by itself. Fire, which is so if expression 1, then expression 2, return true, else return false. All right, let's try that. Yay. Let's see, I think their code is exactly the same. Oh, so they're actually checking if expression 1 equals true, right? So this is actually a little different. So I don't actually need to, this is a good point. You can do this, and this is fine. This is, again, this is another one of those things where it's like, if you came to me and you're writing code like this, this works. If you can write code like this, just not necessary to check if this is going to equal true, because it's a sufficient condition unto itself. So we can just do that. Is either even or. So this takes in two numbers, and let's see, it takes in two numbers as parameters and returns true if either number is even, or if both numbers are 7. Okay. So let's see. Let's see. I wonder if it's going to let me use or here. So I can say, just do mod, mod 2 equals 0. So if either number is even. If num1 mod 2 equals 0, return true. And then we can say elif num2 mod 2 equals 0. We can also return true. Then we can elif num1 equals 7 if num2 equals 7, return false. Oh, excuse me, true. So this is, again, this is our and, right? This is where we have the consequent of the parent is only another conditional check, then we can return true. Or then, like, this is equivalent to an and. So this checks if num1 and num2 are 7. So I'm trying to do this without using or and, even though I think I can in this one. We'll try that way in a second. So if none of these were true, we can just say else false. Return false. We can do that. And we actually don't even need the else, since if it makes it through all that, it's just going to return false anyways. We'll just do that. Cool. Or we'll try that real quick. Wonder if I can get this. Okay. So we can say return num1 or num2. So num1 equals try to cram this in. Num1 one scenario. So that's, oops, that's a condition all by itself. And it's also an operand for another or. So if both of those end up being when num1 and num2 are equal to 7. Equals 7 and num2 equals 7, right? So I think this should do it in a line if it'll let us use or and. Let's see why. Okay, cool. Let's me do that. And that's the same logic as here. Quick recap. So let's try to make this a little more tolerable. This is, you know, there's a lot going on here. Logical operators and a lot of kind of checks going on here. This is not necessarily bad, but this is the sort of thing where I would probably do this. Yeah, I might break it up like that, and this makes it a little easier to read. It makes each line not like insane, right? And the backslash just says like, hey, just let me skip this line. Let me break this on to the next line. And scenarios where you can just would have been on one line, but I want to spread it across multiple lines. So that, I think that makes it a little easier to read. Oh, that's actually kind of nice right there. Ooh, make this even nicer. Okay. Code beautification. Dare I? Yes, I'm going to go all the way. I'm going to be real OCD about the prettiness of this code. Yes. Lovely. That's just wonderful. Okay. Nobody cares but me, but that's fine. All right. Is either even and less than 9. All right, so is either even and less than 9. It's like almost a tongue twister. Is as parameters and returns true if either of the parameters is even and both out num1 mod 2. So this will tell me if equals 0. If, and you know, actually, I should do that. Right. So I should check if it's less than 9 first. I think that'll save me a little. I don't know. Maybe not, but I'm going to do it that way anyways because that's how it seems right now. If num1 less than 9, if num2 less than 9. Now, if num1 mod 2 equals 0, we can return true. If num2 mod 2 equals 0, remember both of these lines, if the mod lines, the modulo lines, if this just tells us if that number is even, then we'll return true. I guess I can put an elif there. That'll make it slightly better. Okay. Now I could put an else return, and we'll just return false there like that. Let's see what happens. Okay, cool. Wrangle this down into a single line here. So, actually, no. Let me. Did I? Oh yeah, I did. That's fine. Okay. So, if both are less than 9, and num2 less than 9, oops. So this is a complete, that's enough to, oops, again, I do this, there we go. That's enough to contain in a set of parentheses. And so if that is true, and this other thing is true, what's the other thing? The other thing is 0. And we'll just, this is starting to get prettier, but yeah, that's good. Cool. And let's look at when they're saying if 1 mod 2 equals 0 or num1 or num if that doesn't return, or excuse me, return true. If that doesn't return true, then it's going to go on to the next line and just return false. So it's a de facto else in that case. I would, and with this, something that's slightly more Pythonic, sort of in between this solution and the suggested solution would be, I would just make this an and, tab this back, tab that back, and then just throw a backslash right there. And that just unnests that. That's all that does. And this is essentially logically identical. And then I'm going to be OCD about making it really nice. Yeah. Okay, cool. So, yeah, that's another solution. Oh, I did something wrong. Oh, yes, I forgot the slash here, backslash. Somehow. Okay. I want to do sort of a recap of this. So, what have we covered? We've covered if, we've covered the 3 conditional keywords, which are for creating conditional code. If, elif else, right? We've covered creating the conditions themselves that actually gate those, the if and elif, the upper two conditional keywords. So some of those operators are the comparison operators. That'll be equal to, not equal to, less than, greater than, less than equal, greater than equal. And we've covered the logical operators, which both take booleans and not, and or. Bam. If else, less or equal, not equal, less than, greater than, less than equal, greater than equal. So these are tools to help you gate the conditions of if and elif, and these are tools to help you create conditional logic, right? These are not the only things that you can use in a condition. Not every condition will have these. I don't know if it's right to say that most will. Many will. I mean, very many will. You'll need to know how to use all these. This is a very sort of central, obviously not going to go into detail because that's what we just did. But these are the things to remember what they do and the way to fit this into the puzzle piece, into the, when you're putting together like a map of programming is these together are sort of the basis. And again, not every condition will have these. Some have none of those. Some have obviously multiples of those operators. But understanding this is the basis of writing your program on if it's false. This is the basis to understand. So, cool. All right, so we'll do another 15 minutes here. Lists are very useful. So lists are a data type. So you can think about these as they do something different than the examples that I'm going to show here, but they are the same kind of thing as integers. Let's do this. Data types. We have integers, float, string, str is the identifier. I'm going to use the Python identifiers. String, bool, none. Why can't we have talked about tuples? Well, they've come up, although not really explicitly, but we've talked about them. I'll leave them out for now. Okay. So these are all what's called scalar types. What that means is that you can put them, so one thing is you can put them in a variable, and that variable is the identifier that points at the data of one of these types, of one of these given types, right? So you have your identifier pointing at some data of a given type, that's a variable. You can change the value that identifier, x equals 5, and then I say x equals 10, right? That doesn't change this 5, right? And why would it? It doesn't need to, right? It's just going to say, well, 5 is 5, and x points at 5, and, well, now x points at 10. So it's just going to point at a different number. So that's something important to understand. That behavior is true about all of these, and that is what defines scalar types or simple types, we can also call them, at a time, and the state isn't subject to change. The variable is subject to change what it points at, but the state of that object pointing at it can change, or the parameter can change, or whatever. Lists are the first of three collection types, or sometimes called compound types, that we're going to talk about within the scope of premium prep. So lists are data types like these, but they're a collection of other data types, and the list itself can change. We'll get into that. So we'll call this scalar. I'll call these simple and or collected. No, I like collection. Collection types. Okay. So simple types are these ones, and the collection type, the first collection type we're going to learn is the list. Lists. So how is it different? So a list, the way you declare a list, you start with square brackets. That's brackets like these that are square. And in here, we can put objects of any other type. 46, and we can put in floats. We can say 4.3. I know where all my keys on my keyboard are. We can put in a string, hello. We can put in a bool, true, false, whatever. We can put in a none type, right? So we can put in all the other types in here as much as we want, right? We can just fill those up. And we can actually even put in other lists. There's no reason why we can't do this. We can say this list has a string and a number, and it could even be a variable. We could say x equals. We could do that. And we'll just put in something else, put in false. Okay. All right, so this is, we're going to get into kind of the details of making wacky lists like this. Most of your lists aren't going to be ridiculous like this list is. So LST. I often do just name, if I have a list, just that's some arbitrary list and I don't really want to think about what to call it, I'll call it list, but I spell it LST. LIST list is a reserved keyword, and it's actually the type identifier for lists. So you don't want to override this. This is one of those keywords that Python will let you overwrite, but hopefully if you just want to call your variable list, LST is common shorthand for that. Okay. Cool. So that's how you declare. So we want to be able to recognize a list, understand the concept of a collection, generate a series of numbers using range. So range is a built-in function that gives us something back that is kind of like a list. It's called a generator, and it's not really a data type unto itself, but it's sort of, in certain cases, it acts like a list, and it can be converted into a list really easily. Access of value in a list. So obviously, you know, we have stuff, we might have like a huge collection of objects, like numbers or strings or other lists or what have you. We probably want to be able to like search through that list and like find specific things and say, you know, what's the information at this specific part of the list, right? What's the data type being held there, right? For a membership. So often you want to say, you know, you have some big collection of things and you want to say, hey, is this object a member of this list? Is it specific, right? So this is what's meant by a nested list. When you have a list that is a member inside another list, it is nested. It is said to be nested in the outer list. The inner list is the nested list. Some assumption that isn't landed. Cool. Okay, so a list type doesn't matter, right? It doesn't matter what they are, just any arbitrary object, any old object. So lists are a collection of any old object that you please, often called an array in other programming languages. Some, like JavaScript has a data type called an array that I think it's safe to say functions exactly like a list, or Java or Rust, or there's several other languages. The array is similar but has some pretty key differences as well. So if you're coming from another, I guess if you're like coming from Java, right? So you don't have to say that strings or an array of float objects. So if you're not coming from Java and that doesn't make sense to you, what I just said, don't worry about it, or another language or whatever. Okay, so the contents of a list can be thought of as ordered. This may seem like a given, like, yeah, why wouldn't it? Let's talk about that. So what that means, if I print out this list, actually let's do this. Let's make this a little more, 9. Okay, so I print out list, I'm gonna get the list with the objects 5. You get what, like, would you get it in a different order? That'd be random and weird. And there are other data types where it's a feature of lists that this in a list. But we'll get to we'll cross that bridge when we come to it. I guess for now, what I'm just trying to get at is that's not a given, and that's an engineered feature of a list. Let's see. The items and I'll get back to what that means and how to deal with that in a second. The items or elements of a list can be accessed by the numeric index in Python. In Python, a list is mutable. Mutability has to do with the difference between the simple and the simple types are immutable. Mutability is the ability for the list to change. By naming its identifier, which is LST, I can say LST, and I can add something into it. I'm going to use a method called append. So hey, and that'll append, meaning it puts it at the end on the right-hand side of the list. There you go. So that changed. That didn't point the variable at a new. Notice I didn't say list equals. I didn't like point the variable at a new list. This list in memory in the program, string or float or in an earlier lesson, but we will be revisiting this later. Okay, to an arbitrary depth, that means you can have as many nested lists inside. You can have a list inside of a list in a list and a list and a list. A couple crazy, and lists within lists within lists to an insane arbitrary depth, then yeah, probably make the choice not to do that. The contents may be ahead. A list is mutable in the sense that its contents can be rearranged, replaced, or deleted. Also, new contents can be added, as we just saw with append. We just added some new contents. A list can be nested. The list data type is the primary construct on which you this thing about indices. I always say indexes. It's indices, and I know it. Right. So indices. So along with each of these elements in the list, the actual values I'll generally refer to as elements. along with each of these elements is an implicit numeric index that corresponds with that element. So the first element, the left-handmost element, the first element, is going to be index 1, the next one index 2, index 3. It's in Python, and there is an exception. I know of a language that uses 1-based indexing, but every other language that I know, and most programming languages use 0-based indexing, as does Python. So 0-based indexing means start at 0, 1, 2, 3. The element at index 3 is 9. Okay, so how do we actually use that? So I list at a given index. We'll list, which is the number of the index that I want. So if I want index 3, I'll just print that out, list sub 3. And often this will be referred to as subscripting, or I'll just say list sub 3, right? Cool. And that'll give me the element 9. So the element 9 is the element at the... Think about, like, when I first heard about it, I was like, what? What could it be? I definitely thought it was weird. So list sub -1 is going to be the last item in the list. Sub -1 is going to be this 4 right here. Sub -3, think about that for a second. -1, -2, -3. That'll be 3. So let's do -5, and that'll be this 9, right? So we can do -1, -2, -3, -4, -5, and that'll be that 9 right there. So that's a little bit about indexing. So this is how you can store objects in a list, elements in the list, and changing and transforming the list, indexing and slicing. But this is how you can put things in a list and then specify a specific item to be retrieved, and you can do whatever you need to with that item. Cool. Okay. So that's a little, I guess this is a little taste of what we'll be going over next time. That'll be Monday, what is that, the 19th. We'll be diving into this and talking more about lists. There's a lot to go over with lists. Well, I'm actually with lists. You can get a lot done with just a few tools, but there are a few tools and there's a few things to understand. So